Hey everyone, today we are going to solve a popular Leetcode problem called last stone weight. This problem is a great way to practice using heap, specifically max heap in C++ to solve the problem. In this video, first we will break down the problem, look at an example and then code up a solution step by step in C++. By the end of this video, you will not only have a solution but also deep understanding of using heaps in C++. So let's get started. Let's start by understanding the problem first. So we are given an array of integer stones where stone I is the weight of ith stone. On each turn, we choose the two heaviest stones and smash them together. If the weight of both stones are equal, both stones will be destroyed. However, if they have different weights, then the weight of heavier stone is reduced by the lighter one. And we will keep repeating this process until there is only one stone left or no stone at all. The final answer is the weight of the last remaining stone. If there are no stones left, then we will simply return 0. So let's walk through an example to understand this better. Suppose we have these stones and we want to find the last stone weight. So in each round, we pick the two largest stones and smash them together. Here is how it would look like. So first time we will pick the two heaviest stones. In this current array, the heaviest stones are 8 and 7. So I will pick 7 and 8, smash them together. 8 minus 7 is equal to 1. So I'm left with 1. So I will remove 7 and 8 and I will be left with 1. Second time I will pick 4 and 2 because these are now the heaviest stones. I will smash them together. 4 minus 2 is equal to 2. So I'm left with 2. Next, the two heaviest stones are 1 and 2. So smash 2 and 1 together. 2 minus 1 is equal to 1. So I'm left with 1. So I will add 1. Next, all stones weight is equal to 1. So we will pick the heaviest stones will be 1 and 1. So if we smash them together, 1 minus 1, they will cancel out each other. So both stones will be destroyed. Finally, we have just one left, and that is this weight of our last stone weight. And that is our answer. If no stone would have left, then we would have to return 0. Okay, now let's think about the approach we will take to solve this problem. There are two key operations here. First is getting the heaviest stones repeatedly. And second is updating the list of stones based on the result of each smash. The best data structure to handle this problem would be a max heap because it allows us to efficiently retrieve and remove the maximum elements. In C++, we can use the priority queue container as a max heap by default. Let's quickly discuss this time and space complexity of this solution. Since we are using a max heap, Each insertion and deletion operation takes log of n time, and in the worst case we will perform this operation n times, resulting in an overall time complexity of n log of n, and our space complexity is O of n due to storing all elements in the heap. So first we will initialize our priority queue with all the elements in the stones array. By default, this creates a max heap where the largest element is always at the top. Now we will start a loop that continues as long as there is more than one stone left. Next, we pop the two largest elements, first and second. Now we need to check if they are equal. If the stones have different weights, we push the difference back into the heap. If they are the same, we do not push anything since they cancel each other out. And finally, we return the remaining stone if there is 1 or 0 if the heap is empty. Now let's try to run the code. As you can see, all the test cases are okay. And this is a kind of most efficient solution for this problem. You can also find the solution for this problem in the description box. To summarize, we solved the Leetcode's last on wait problem using a max heap, which allowed us to efficiently access and manipulate the heaviest stones at each step. This problem is a great example of how heaps can be leveraged to implement a greedy strategy. If you found this video helpful, don't forget to like and subscribe for more coding tutorials. And that's it.